Hi students, so today in this video we are going to learn image formation by mirror as well as lenses. Okay, so we are learning spherical mirrors. So spherical mirrors are of two types, concave mirror as well as convex mirror. Okay, so concave mirror, let's learn first what is a concave mirror. Concave mirror is a spherical mirror whose reflecting surface is curved inwards as you can see in this picture. Okay. In this picture you can see that there are some markings also given. So F here means focus, C means center of curvature, P means pole. Okay. Now the distance from pole to F, that is focus, from pole to the focus, the distance is known as focal length. And you need to know that radius will be twice F. F is focal length here. Okay. Similarly, convex mirror, they are the spherical mirrors whose reflecting surface is curved outwards. Okay. So first we are going to learn ray diagrams by concave mirror. Okay. So to learn the ray diagrams, we need to know that if there is a particular object, okay, through that there can be infinite rays which are falling on the mirror. Okay. But out of that, we are just taking some standard incident rays which are given to us. Okay. And in our textbook, we are given 4 incident rays and we are going to learn its path through which it gets reflected. Okay. So these are the 4 diagrams given to us. There are 4 ray diagrams of concave mirrors. Okay. So in the first case, the incident ray is taking this path. Suppose this is the object here. The incident ray will be parallel to the principal axis. Principal axis is this, PC. Okay. So this incident ray is parallel to the principal axis. After reflection, it will pass through the principal focus. Okay. So as you can see the arrow, this is coming in this path and it is moving, it is getting reflected to this path. Okay. So it is moving to the point which is known as focus, principal focus. This is the first case. Okay. Whereby the incident ray is coming parallel and it is passing through the principal focus. Next will be the incident ray is coming through the point principal focus and falling on the mirror, and on reflection it will go parallel to the principal axis. So in the second case it is following just the opposite, it is just the opposite of the first case. Okay. So in the first case it is coming parallel and going passing through the principal focus, and in the second case it is coming from the principal focus and passing parallel to the principal axis. Okay. Now the third case. In the third case, the incident ray is passing through the center of curvature and falling on the mirror. Now you will wonder where is the reflected ray. But in the third case, the reflected ray will take the same path and it will move through the center of curvature itself. Okay. Because it is making here 90-degree angle. Okay. So that's the third case. Last case is when the incident ray falls on the pole, it follows law of reflection, whereby angle of incidence is equal to angle of reflection, and on reflection it follows this path. Okay. So these are the 4 ray diagrams you need to learn first before we go for image formation by concave mirror. So I hope you will learn this, and now let's look at image formation by concave mirror. So we have seen that from an object there can be infinite number of rays falling on the spherical mirrors, right? But out of that we are just learning some of the standard incident rays which were given to you in ray diagrams. Okay. Now you will be learning here image formation by concave mirrors. For image formation, there needs to be interaction of 2 reflected rays. Okay. So we will be taking any standard incident ray which was given to you in ray diagrams, and when they will get reflected, the intersection point will give you the position of the image. So under image formation there are 6 cases given to you. Out of that we are learning the first case now. In this the object which is located at infinity. Okay, so the object is not located anywhere on the principal axis. Now, how will you locate the position of the image? So let's take the first case of ray diagram whereby the ray comes parallel to the principal axis, and when the ray comes parallel to the principal axis, after reflection it passes through the focus. Okay, so after reflection it passes through the focus. So this is the path which this ray has taken. Now, second ray you can take anything from the ray diagrams, but here we are taking the ray is coming parallel to the principal axis, and after reflection it will follow the same path which it followed in the first case. So it will pass to the focus. Okay, so it is coming from this path, it follows this path. So you can see that these are two reflected rays. Okay, so these are two reflected rays, they both meet at this point. So this is the intersection point of those two reflected rays. So the intersection point gives you position of the image, right? So the position of the image is at focus, and you cannot even see it properly. So you have to say it is highly diminished, or you can also say that it is point sized. Now you know that the image is formed on the same side as the object, where the object is kept towards the same side the image is formed. In that case, the image you will say as real and inverted. So this was the first case which was given to you out of 6 cases on your textbook. In the second case, your object lies beyond C. Okay, so object is located beyond C. Okay, here you can see the object. Object is named as AB. Okay, in this case, first ray we are taking parallel to the principal axis. Okay, so this is the ray which is passing parallel to the principal axis. After reflection, it will follow the same path which was given to you in the ray diagram. It will pass through the focus. So it is passing through the focus here. See, this is that ray. So this is the path followed by the first ray. It is passing through the focus. Now you can take any ray as the next ray, but here we are taking the ray which is passing through the center of the curvature. You remember, if the ray is passing through the center of curvature, it will follow the same path on the reflection. Okay, so that is, it will pass through the center of curvature again after reflection. Okay, see, both arrows you need to show. Now you need to look at where both the reflected ray are meeting, intersection point. So it is here, meaning this will be the position of the image, okay, which you have to mark as A dash, B dash. Okay, now if you look at the image, it is not that big also, so you will write the position of the image will be between F and C, or C and F. Size of the image is diminished, and the image type is real and inverted. Okay, so that was second case. Now let's look at the third case. In the third case, the object is located at C meaning center of curvature. Okay, see, you can look at this figure here, but when you are drawing the diagram for at C, it is not, you are not going to get the diagram as it is, so you need to use your scale, okay, to mark the things. You need to take proper measurements and then mark the image at C. Okay, so you need to take the measurement here. You can take this as 5 centimeter maybe. If you are taking this image of 5 centimeter if you are marking, then from that you can take the first ray. First ray is parallel to the principal axis. It will pass after reflection to the focus. Next, if you are taking the next ray as passing to the focus, this ray is passing to the focus, then after reflection it will go parallel to the principal axis, right? So where it is meeting, at that point the image is formed. You need to get the position of this image at C only. When the object lies at C, the image will be formed at C. But if you are not getting the image at C, then you need to use the measurements. So suppose you are marking this as 5 centimeter. Also mark the object as image as 5 centimeter here. Okay, so suppose this is AB, this will be A dash B dash. Okay, so both sizes you mark first and then you mark the rays accordingly so that you get the image at C itself. Okay, so the position is at C. Size, it's of same size and it is real and inverted. Okay, so this was the third case. So now we have the next case. In this case, now the object is located between C and F. Okay, so object is located between C and F, and if you look, the image is formed beyond C. So this is similar to that case which we had studied where the object was lying beyond C and the image was formed between C and F. So this is just the opposite of that case. Okay. Now here the image is kept, the object is kept between C and F. Okay. In that case, image was formed between C and F. Okay. Now the object is kept between C and F. Okay. So first ray will go parallel to the principal axis. After reflection, it will pass to the focus. Okay, so this is the path followed by the first ray. Now second ray, as it was told, you can take any ray as the second ray, but here it is given, it is passing through the center of curvature. Okay, so when the ray is passing through the center of curvature, after reflection, it will pass to the same path. Okay, so when both these rays meet, the intersection point is here. So the image is formed at this place. Okay. So the image is marked as A dash B dash. Okay. And as you can see, the object is smaller and the image which is formed is big. So the position, so the size of the image will be enlarged. And position of the image is beyond C. Type real and inverted. Similarly, we have the next case. This was one diagram, and every time when you are drawing the ray diagrams, take proper measurements and mark the things like CF and PF will be equal in distance, okay, equal length, because R is equal to twice F, right? So accordingly you have to mark the things. Now the next case, in this case the object is located at F, and this is the same as the first one that you studied where the object was locating at infinity and where the image was formed at F. Okay, now here it is just the opposite. Object is kept at F. Okay, and you can see first ray is passing parallel to the principal axis. After reflection, it will pass to the focus. So after reflection, it is passing to the focus. Second case, second ray is passing through the center of curvature. After reflection, it will follow the same path. Okay, so these two rays will not meet on your page. It will meet somewhere at the infinite point. Okay, so the position of the image is at infinity. Size is highly enlarged. and type is real and inverted. So this is the last case. You are learning image formation by concave mirrors. Okay, and in this case, the object is kept closer to the spherical mirror and it is kept between F and P. So the object is located here. Okay. So from here, first ray we are taking, it touches pole. When it touches the pole, it follows law of reflection. Angle of incidence is equal to angle of reflection and it passes this way. So the path is shown here. Next ray we are taking passing through the center of curvature. If it passes through the center of curvature, it will come back in the same path. Okay, so if it is coming this way, it will follow the same path and it will go back in the same path. Now in this case, this is the last case of concave mirror, and in this case the image formed is virtual, which is forming behind the mirror. Okay, so we are tracing the reflected rays back, the path of the reflected rays we are tracing it back so as to get the position of the image, and the image is formed behind the mirror, it is enlarged and it is virtual and erect. Okay, so now we are going to learn ray diagrams by convex mirrors. Convex mirrors, as you can see, the reflecting surface of the convex mirror is curved outwards. Okay, so first ray will come parallel to the principal axis, as you can see here, and it will appear to diverge from the principal focus. So it will move in this way. Okay, so this is the first ray diagram. Second ray diagram is similar to that of concave mirror. Just you need to show the extension here. Okay. Now second ray will be directed towards the principal focus, as you can see here. Okay. After reflection, it will go parallel to the principal axis. It will emerge parallel to the principal axis. So these are the two rays we are learning. So see, first ray is coming parallel to the principal axis, it will diverge from the principal focus. Second ray is falling on the principal axis, it is directed towards the principal focus, it is directed towards the principal focus. So after reflection, it will emerge parallel to the principal axis. Okay. So as you know that you have four ray diagrams for concave mirror as well as convex mirror, and we have seen two ray diagrams for convex mirror so far. Now the next two we are looking now. Okay. So in case of third ray diagram which is given to you, the ray comes in this direction. So as you can see in the figure, ray is falling on the center of curvature. So it is directed towards center of curvature. When the ray comes towards the center of curvature, it follows back the same path. Okay, so after reflection, it will go back in the same path. Okay, and this happens because this incident ray is falling on the mirror along the normal. Okay, so it is making a 90-degree angle here, and that's why it is taking the same path back. Okay. Now, the next one is a very easy one. Here, the ray is falling towards the pole, and after reflection, it will follow law of reflection, and it will go in this direction. So that angle of incidence is equal to angle of reflection. Okay. So these are all four ray diagrams for convex mirror. Now, by using them, we are going to learn image formation using convex mirrors. Okay, so now we have image formation by convex mirrors, and there are only two cases given to us in case of image formation by convex mirrors. Okay, so the first case is when the position of the object is at infinity. Okay, the object lies at infinity. Now we are going to do ray diagram to find out where the image is formed. Okay. So in the first case, the ray will come parallel to the principal axis. As you know, you can take any ray from the ray diagrams, but let's take the same one which is given to us on the textbook. So first ray comes parallel to the principal axis, and after reflection it will go in this path and it will appear to diverge from the principal focus. Okay, so this is the first ray. Second ray again is coming parallel to the principal axis. After reflection it will appear to diverge from the principal focus, and this path it will take. So as you can see, two rays are meeting after reflection at this point. Okay, so the image is formed here. So the size of the image, as you can see, it is highly diminished or point sized. Okay, and it is located on the other side from where the object is kept. So it is virtual and erect. Okay, so the type of the image which is formed is virtual and erect. Okay, now coming to the second diagram. Here the object is kept near. Okay, that is, it is between infinity and the pole. Okay, between infinity and the pole. So in this case, first ray is coming parallel to the principal axis here. After reflection it will appear to diverge from the principal focus and it will take this path. Next ray is coming towards center of curvature, as you can see, and it will go back in the same path. The ray which is coming towards center of curvature takes back same path after reflection. So as you can see here, the arrows, okay, and these two rays after reflection they meet at this point. Okay, so the image is formed here. So the type of the image again is virtual and erect, and the image size is diminished. Okay, so this is the second case, this is the first case. Now let us understand spherical lenses. Under spherical lenses we have concave lens as well as convex lens. Okay, so let us understand the distinguishing point between both the lenses. Here you can see the image of it. Okay, so the convex lens. Convex lens is a lens which has two spherical surfaces which are bulged outwards. Okay, and concave lens is a lens which has two spherical surfaces bulging inwards or which are curved inwards. Okay, now convex lens is also known as converging lens because it converges the light rays which falls on it. Okay, and in case of concave lens it is also known as diverging lens because it will diverge the light rays which fall on it. Okay, now next you need to know that this spherical lens, convex lens, it is thicker at the middle than the edges, whereas the concave lens is thicker at the edges than the middle. Okay, so these are the distinguishing point between the two lenses. Okay, now one more thing you need to note here. In case of mirror, the center point on the spherical mirror, surface of the spherical mirror is known as pole, and in case of lens, the center point is known as optical center. Okay, so it is denoted by O here, and in case of mirror it is denoted by P. So now let us understand ray diagrams for lenses. Here I have already drawn ray diagrams for concave lens as well as convex lens. Okay, so let us understand first convex lens. These are three different cases in case of convex lens. So first ray comes parallel to the principal axis. Now you can see that these are two spherical surfaces of the convex lens. This is the optical center. This is F1. This is twice F1, which is same as C for the mirrors. Okay. Now the ray of light comes parallel to the principal axis. After refraction, it will pass to the principal focus on the other side of the lens. Okay. So after refraction, it will pass through the principal focus on the other side of the lens. So this was the case when the ray comes parallel to the principal axis. In case of convex lens, okay. In case of concave lens, if the ray of light comes parallel to the principal axis, as you can see here, it will take this path. after refraction, okay? But it appears to diverge from the principal focus on the same side of the lens. In this case, it was happening, it was meeting the principal focus on the other side of the lens, and in case of concave lens, it appears to diverge from the principal focus on the same side of the lens, from where the ray came, okay? Now the second case. In the second case, the ray of light passes through the principal focus, okay? After refraction, it will pass parallel to the principal axis, okay? On the other side, it will pass parallel to the principal axis on the other side. Now in case of concave lens, a ray of light it appears to meet the principal focus here. See, as you can see, and instead of meeting here, it will get refracted and it will pass parallel to the principal axis. Okay, so the ray of light which appears to meet the principal focus of the concave lens, it appears to refract in parallel way on the same side of the concave lens. Okay, so these were the two cases of ray diagrams for concave lens as well as convex lens. Now we are looking at the third one. Okay, in the third case for the convex lens, the ray of light touches the optical center, so it moves through the optical center, and when the ray of light moves through the optical center of the convex lens or the concave lens, it emerges without any deviation. Okay, so it will pass in this path only in both the cases. Okay, so those are these three are the ray diagrams for concave lens as well as convex lens. You can please note the differences in both the lens and study them so that it is easy for you to understand image formation by the lenses. Okay, so let us understand image formation using lenses. First is convex lens, and we will be using the ray diagrams that we just now studied. Now you need to know one thing, that convex lens will show similar kind of circumstances as you have studied in concave mirror. Okay, and concave lens will show similar to that of convex mirror. Okay, so convex lens which has similar circumstances as in case of concave mirror. So first one, when the object is at infinity, the first ray will come parallel to the principal axis, and after refraction it passes to the principal focus, which is shown here, and the same happens with the other ray which comes parallel to the principal axis. It will pass to the principal focus. So the position of the image is here. It is located at f2. Okay, and the size of the image is point sized or highly diminished, and the type of the image here is real and inverted because convex lens shows the same kind of things as you see in concave mirror. Okay. Next is when the object is located beyond to f1. It is same as beyond C in case of mirror. Okay. So beyond to f1, you are marking the object here. First ray comes parallel to the principal axis. After refraction, it passes through the principal focus here. Okay. Next ray we have taken is the one which was passing through the optical center. When the ray of light passes through the optical center, it will emerge without any deviation. So this is its path. Okay. So both the rays after refraction are meeting at this point, which is between f2 and 2f2. Okay, which was same as between C and F in case of concave mirror. Okay, so this is the second case whereby the object is diminished. Location is between f2 and 2f2, and type is real and inverted. Okay. Next is when the object is located at 2f1. If you remember, in case of concave mirror, when you were keeping the object at C, the image was formed at C itself, and the size of the image was same as that of the object. Okay, here also same thing is happening. So the object is kept at 2f1. First ray comes parallel to the principal axis. After refraction, it will move to the focus, which is f2. Next ray is passing through the optical center. so it won't deviate, it will take the same path. So both the refracted rays meet here at 2f2. Okay, so the object and image is of the same size. Location of the image is at 2f2 and it is real and inverted. Okay, so this is the third case. Fourth case. In fourth case, now we are placing the object more near. Okay, so it is between 2f1 and f1, which was same as C and F, between C and F. Okay, so the object is placed here. Ray comes parallel to the principal axis, passes through the focus. Second ray passes through the optical center. Without deviation, it moves in this path. So it will meet after refraction. Both the rays are meeting here. So this is the position of the object. Object is always marked as A dash, B dash. Okay. So the object here is enlarged. The position of the object, position of the image. Object is here. Position of the image is beyond 2f2. The image is real and inverted and it is enlarged. Okay. So these are the four image formation diagrams you have studied. Now let's learn next two. Okay. So now let's learn last few diagrams that are left of convex lens, and after that we will learn concave lens. So convex lens. Next case is when the object is kept at f1. Okay, so the object is kept at f1. The first ray will pass parallel to the principal axis. After refraction, it will meet the principal focus on the other side of the lens. Next ray is passing through the optical center. It will emerge without any deviation. After refraction, it will emerge without any deviation. Both the refracted rays after refraction, they are not meeting at anywhere on your page. So the image is formed at infinity. So what you will say, the position of the object is at f1. The image formed will be at infinity. So the type of the image is real and inverted, of course, and the size of the image will be highly enlarged. Okay. Next case is when the object is kept between f1 and O, that is optical center. Between f1 and the optical center. So the object is kept here. First ray comes parallel to the principal axis. It passes through the principal focus on the other side after refraction. Next ray will pass to the optical center, and without deviation it will follow this path. But the image in this case is formed on the same side of the lens, which you can see here is marked as A dash, B dash. So the image is formed on the same side of the lens. Okay. So this image is known as virtual and erect. Okay. This is the last case which you have also studied in case of concave mirror. Okay. So concave mirror and convex lens shows the similar circumstances, as you know. So this is the last case of concave mirror as well. So in this case the image formed is virtual and erect. Okay. And the size of the image is enlarged. Okay. So that's all about convex lens. So we have studied 6 image formation diagrams in case of convex lens. Now let's move to concave lens. In case of concave lens, just like you had just 2 image formation diagrams for convex mirror, like that, same it is for concave lens. Okay. So the first case is when the object is kept at infinity. The ray comes parallel to the principal axis. After refraction, it takes this path, but it diverges from principal focus on the same side of the lens. Okay. So object was this side, it diverges on the same side of the principal focus. Okay. So the image is formed here. That's why it is highly diminished, point size, and virtual and erect, because it is formed on the same side of the lens. Okay. And you know, in case of convex mirror also, the image is formed in both the cases are virtual and erect. Okay. Next case is when the object is kept beyond to F1, but this is the case where the object is kept between infinity and optical center. It is not that it is kept just at 2F1. It is the case when the object is kept between infinity and optical center. Okay. So the first ray comes parallel to the principal axis. After refraction, it takes this path, appears to diverge from the principal focus on the same side of the lens. Next ray passes through the optical center. In case of optical center, for both the lenses, it passes through the optical center. It follows the same path and without any deviation, it follows the same path. So this is the path it takes. Both the refracted rays meet at this point. So this is the place where the image is formed. Okay, it is diminished. So this is A dash B dash, and the image is formed on the same side as that of the lens. So it is again virtual and direct. Okay, but the size of the image here is diminished, not highly diminished, because you can see it. Okay, so this is all about image formation in case of mirrors as well as lenses. I hope you have understood and you will practice even more.